Howdy everyone, this is Ari Danish with Side Effects, and today I'm going to do the second intro tutorial into PDG. Specifically, we're going to talk about particle stream wedging with PDG and do a simple top setup. A very common question that people who are new to Houdini ask me is, should I use VOPs or Vex and Wrangle nodes to solve my C-node problem? And I always have a stock answer for that, and that is, if you're experimenting or just playing around to get a cool effect or solution, use VOPs. VOPs is a great playground. But if you really know what you want to accomplish, if you know the equations, then go to Wrangle nodes because Wrangle nodes is much easier to read. The equations are concise in one line, and it's not reverse Polish like VOPs is. So what does that have to do with PDG? Well, actually nothing, but I get this new question. Should I do a Houdini network first and bring it into PDG? Or should I just drop down a top network and try to build it all in within the top network? Well, PDG is now mature and robust enough to accomplish your Houdini workflows in either of those ways. Create a traditional Houdini network. If you already have an existing network, might as well use it and just have pointers into your PDG network. Or if you're just playing around for, again, a cool result or effect, might as well just work completely in Houdini and then worry about PDG when you're building it. So what would you do? You would build your Houdini network in SOPs or DOPS or wherever, test the Houdini network to make sure it performs as expected, then create the TOPS network with pointers to parameters in SOPs or DOPS or to the HDAs that you created. But the other approach, which again, I'm just saying it's getting mature enough now to do, is build a top network and embed all your Houdini logic within it. The choice is yours, and I'll show you in this tutorial both ways of doing things. We'll start with the traditional, build the Houdini first, understand what's going on, and then what we'll do is we'll just build it completely in TOPS. In this tutorial, we're going to focus on a few top nodes. We're going to learn about the wedge top, the partition top, the geometry wrap, which we did in the previous tutorial, but specifically on the second part of this tutorial when we embed everything in a top-centric workflow, there's a few new little tricks that I wanted to show you with the geometry wrap. We're going to talk about Image Magic, which is a separate third-party program that you can download for free and install, and then you have image compositing capabilities within your top workflow. We'll talk about the wait for all top, which used to be called the partition all top. And then finally, you got all those images and you want to make an MP4 out of it. We have the FFmpeg encode video top, which is also a third-party plugin that you'll have to download and install, but it's also for free. So I want to do a really simple Houdini network because this tutorial is not really about Houdini. It's about PDG and TOPS. So I want to create something that everyone would understand. So we're going to just do a simple little particle stream with a particle curve force. And what we're going to do is we're going to wedge a bunch of these particle bursts. So we can then composite all the particle bursts to get a smoother particle stream at the end. And as I said before, we'll start with building the Houdini centric approach, and then at the end we'll convert it and show you how to do it strictly in TOPS. Here I am in Houdini, and I already built the bare bones particle stream network. Here's the end result of it. You see it's just basically particles going through a pop curve force. Houdini 101, but we got a particle emitter, which is just a circle. We got a particle force curve, which is just a curve that's been resampled. Then we got our dot network, which has the circle source and the pop color and a pop curve force. Now, for those of you who have watched my tutorials in the past, you know that anything that I want to convert into a HDA parameter, I color code yellow. So I decided that anything that I need for PDGs, I would color code pink. I thought PDG and pink will start with P, so it'll be easy to remember. So in the circle source here, I'm going to want to control the seed values of my wedges. So I want to change the seed values to different numbers so I get different particles. And the pop color, I want to change the pop color itself and control that by my PDG. So those are the two parameters that we will focus on when we create our top network. I should mention, just like any Houdini network that isn't completely trivial, that having a good folder structure for your project is important. So we're all used to having render for our mantra stuff, but I also have images for things that are going to be composited using Image Magic, and I also have a folder here of videos for stuff that's going to be converted to MP4s for with the FFmpeg application. Other things is, again, I need the geo folder because we're going to be creating geometries, and the rest of this stuff is usual Houdini project folders. So we're ready to PDGify that Houdini network that we just created, and I want to reinforce this concept here. When doing it this way, I find this is a really good workflow. We create the basic network, and we set up the shot, cameras, lights, whatever you need. And the reason why is it's much easier now to visualize than, let's say, a month ago, PDG networks, but still, set up your scene and get it the way you want. Makes life easier. So set up your shot, and then you're going to create your PDG, but you're not going to go for the whole shebang. You're not going to say, I need 10 seconds worth of particles and 100 wedges, which is going to lead to hours and hours of rendering time. You just want to test with a very small data set. In my case, I'm going to do 3 wedges and 10 frames, just to prove the logic is good. And these two kind of work hand in hand. This allows me to quickly debug my TOPS network without worrying about, did I run out of memory? Is my network on HQ set up correctly? I want to just focus on PDG. Once I get that running, then change your parameters to run the full data set. Remember, PDG is a templated network. Once you have it set up for small data sets, it will dynamically adjust to any size you want. That's one of the key features of PDG, what makes it so useful. And I'm now going to jump up to the object level of the Houdini network, and I'm going to drop down a top network. When I dive inside the top network, all there is the local scheduler. Now remember, the local scheduler tells Houdini to utilize all the cores of the local machine. We have already nodes for other schedulers, like the Tractor scheduler, the HQ scheduler, and Deadline. And so if you want to run it over a network, these schedules are available to you, or you can write your own schedule with a couple hundred lines of Python. Okay, so I'm going to drop down a wedge top. And remember, a wedge attaches a piece of metadata to a work item. What does that mean? Well, basically, it's going to create for me some work items, and it's going to put some values in there that are useful to me. In this case, some attributes that we'll use downstream to declare what the seed values are going to be in the AutoDOP network and what the colors are going to be in the AutoDOP network. So let's just jump for a second back to that AutoDOP network and see what I'm talking about. If I go to the circle source and you just look at the circle, let's zoom in on that. You can see there's a bunch of particles being emitted, mostly inside the circle. And you can see where the locations are. When I run this, I run one particle stream, and it looks pretty nice. But I want a fuller, smoother effect, maybe different colors for these particles, maybe different sizes for these particles over and over again. So I want to create all these wedges. So if I were to go here manually and change the seed value, and again, focus on this pattern of points here. If I change the seed value from 200 to 500, you'll see that the points actually change in position. And again, say 1,000, 1,200, or 1,200, they change again. So I want to be able to run this stream over and over again with the birthing points being at different locations, and then be able to composite it. Well, I can actually run this AutoDOP network multiple times, one after the other, to get those results that I want and cache it to the hard drive. But with PDG, I could utilize all the cores that I have in the machine and say, per core do a particle stream and then composite it. So I'll get something that's done much quicker, and it's all parallelized for me. So I just have all those streams that we can composite. So that's the first thing that I want to do. And then same thing here. I wanted to have something to be able to control for each particle stream what this color is going to be. Okay, back to the auto network, the top net, dive inside. That's what the wedge is going to do for us. So let's focus on the seed first. So I'm going to say wedge attributes, and I'm going to go here and click positive. So I want one wedge attribute. And the first thing I'm going to have to do is give it a name. So I'll give it the name seed, just like that. Okay. The seed is going to be a float. And then the next question is, how many wedges do I want? And that's taken care of here at wedge count. So I'll say 3. Again, I'm looking for a minimal test group to make sure that the logic is good. Then over here it's going to say, what is your range that you want? And I'll say 0 to 1. No, let's say a range of 0 to 10. So if I run this, I'll go cook, select a node. You'll see I'll get 3 work items. And if I middle click on the first one, you'll see that the seed is 0. The second one should be a seed of 5. And the third one should be a seed of 10. Because I said the range is going to be 0 to 10 divided into 3 wedges. So 0, 5, and 10. I just want to remind you that when you create an attribute name like seed, anywhere downstream in your PDG network, you can reference that seed value by just saying @seed, just like any other attribute in Houdini. In addition, you can reference this PDG attribute or push this attribute anywhere within your Houdini network by just putting @seed inside a parameter. So in our case, I could go here into Houdini and take this seed value, go up to my auto network, and just go into pop source right now and say wherever my seed is, @seed, and it will work. Okay, I'm going to delete that channel for right now. We'll get back to it in a bit. If we look at the wedge type, the default is range, and that's what we use. We set a range of 0 to 10 and divided by 3 for the wedge count. But there are other options. Another option is to directly hard code a value to each wedge, or create a value list for each wedge item. So let me show you how that works. So we go back to Houdini and go back up, top network here, go to the wedge. I'm going to just say dirty all, or select a node, same thing, it's only one node. And I change this range here to a value. And I give the value, 4.2. And now I cook it here, and I say dirty and cook selected node. And I middle click on these guys. You can see the seed for wedge 1 is 4.2. Wedge for wedge 2 is 4.2, or the seed for wedge 2 is 4.2. And finally, it's also wedge 3 is 4.2. So that would just really give a constant for each wedge. But if I change this to a value list, I could say that I have 3 wedges, so I want 3 different values. So we'll just go 2.2, 3.3, and 4.4. And if I now dirty and cook selected node, and now test it, 2.2, 3.3, and 4.4. Another option to do here is, let's change this back to range. And remember when we had it range and I cooked it, we had from 0 to 10, 3 wedges, so 0, 5, and 10. If I go here and say make it random samples, and now rerun it, now you can see I have 7.5, 7.7, and 6.9. So it gives us now random values for each of those 3 wedges. in the range of 0 to 10. Again, if I change this to 100, just so you get it, then you can see I got 75, 77, and 69. Now, let's jump back to the AutoDop network and test to see if this wedge is actually working. So I'm going to go back up, AutoDop network, go into the pink circle source, go to seed, and just change this to @seed. If I left click on it, it's going to say 69.2554, which is what we would expect from that wedge. But more importantly, and really cool, is now if I actually left click on one of these work items to select it, you can see as I click the different work items that my pattern for my birthing particles is different. Very simple setup, and it works. Really cool. So I want to show you a different method of pushing seed into the seed parameter in the AutoDop network. So what I'm going to do is first I'm going to go back up here to my AutoDop network, and I'm going to delete the channel. So you know that we're not driving it by @seed. I'll make it something like 5, and you'll see that it did update here to a different birthing. Then I'm going to drive down into my top network wedge. And what I'm going to do is I'm going to turn on target parameter. What target parameter lets me do is select the node icon and find what parameter do I want to overwrite by default. So whatever I pick here, in our case, object, AutoDop network, circle source, birthing tab, seed, will now be automatically overridden. And the values that we're using the wedge will be used in that parameter. So if I do that, and now I go dirty and cook selected node, you'll notice that in my scene view, if I click any of these nodes, this is not being updated. And that was done on purpose by the designers because they want to make sure that if you set up your like AutoDop network or your SOP network, that you didn't accidentally change the values by doing this. So they wanted to make sure that you wanted to do it. So you have to toggle on override target param on the item selection. Once you do that, you can see it was working just like before. Okay? A question that might be asked is when to use the target parameter versus just putting it the @seed in the parameter you want in your network. And what I'm starting to discover through doing all these exercises is that if I have a lot of parameters in my network that are going to be driven by one attribute here, then I'll put them in the network explicitly with @seed no matter where it's going. But if it's just one item that I'm going to override, and two, if it's just like that particle source where you're going to go object, AutoDop network, then circle source, then dive into the birthing tab, and dive into the C parameter, so it's really nested deeply in, and as you're debugging, you might forget where it is because it is so deep into your network. This is a real nice convenience to have it here just like this. It's time now to start wedging the color. So I want to show you the wrong way of doing it first, and there's a lot of things to learn by doing it the wrong way, and then we'll do it the right way. So let's go and do it. So first thing, I'll just call this wedge seed. And remember, I'm going to do it the wrong way. So if you're following along, you might not want to do this part of it. So I might want to go here and drop down a wedge for a color. And we'll wire it up. And we know that color is a vector. It's a 3-float vector. So our first inclination might be is, well, let's add an attribute. And I'll call this wedge color. Like that. And the attribute type, instead of a float, I might say a float vector. And for each one, I want, let's say, some random samples of color between 0 and 1. So there that is. And I want my wedge count to be 3, as an example. So now I'm going to go and say target parameter. And I'm going to go and find in my DOP network, object auto DOP. I'm going to look for the pop color. There it is. And under the color tab, here's the color field. And there's try to collect that color. I can't even select it because color is really 3 individual floats for color red, green, and blue. So I can't use that vector. So I'm going to have to do a different approach. I might say wedge color red, change that to a float, and say, okay, there's my floats for it. And my target parameter is going to be object dot network particle color and color red. And that does work. Okay? And since our color space is between 0 and 1, that makes sense. A wedge count of 3 makes sense. Life is good here. Now, again, if you watch previous tutorials of mine, I tend to like to explicitly break out everything instead of put everything in one unit. So when I do my transforms, instead of having all my parameters for scale, rotation, and translate in one transform, I break them out into 3 different items. And so my first idea here was, well, that makes sense. Let's just do the same thing here. Copy, paste. So this is color red. This one will be green. And one more. That one will be blue. And so I just got to update this attribute name to be green and change that color R to color G. And same thing here for blue, and change this to attribute name color blue. And I said, okay, I got them overridden. So I'll save. I'll go here, say dirty all, and dirty and cook selected node, sure. And something wrong happened here. So I had 3 wedges originally, and that's what I wanted, 3 streams. But then when I declared here, I counted 3 wedges for the red, it produced 3 wedges for each one of these wedges upstream, as you can see by how it's working on these points here. Okay. Then I did the green, and that then multiplied by 3 again. So now I have 27, and finally blue, I have 81 work items, which obviously I didn't want. I wanted only 3. So then you could say, well, okay, maybe I needed just 1 wedge for each of these guys. And so I'll dirty and cook selected node, and there they are. But now if I look at these guys, I got red 0.23, 0.235 for green, 0.235 for blue. I got all the same values here for each of the red, green, blues. Well, maybe I could change the seed values for each of these guys. 1, 5, and 9. And recook. Dirty. Let's just go here, dirty all. Save. Cook selected node. And 0.463, 0.622, 0.463, 0.62. You can see it didn't work. Okay. So why it didn't work here is, yeah, I had 1 value, but really I'm just keying off the same wedge. I'm keeping up the same values here. What I really wanted to do instead was create a structure for this wedge just like in programming a C structure, or even in VOPs now where we could do a structure. So I'm going to go back in here, and I'm going to add 3 more attributes to my original wedge seed. So this will be wedge seed and color now. So it'll be a total of 4 attributes, and we call it wedge seed. Well, I probably have it even pasted. Nope. Okay, so we'll call the first one wedge seed color. Oops, that's not what we want to call it. Wedge color red. And the target parameter is object topnet. No, we'll have to look at it. Here we go again. Okay, so now we have the template for both. So we could just easily here go paste, paste, and call this green, blue, and then copy this guy, turn on target parameter, green and blue. And I'm going to turn on random samples for each of these guys. So it's not just 0 and 1, it will give me actual real variations of it. Save. Dirty selected node, and now let's run it. I'm going to make sure my overwrite target param is, so hopefully I'll be able to see it in the scene view. And dirty and click selected node. There's one color. Looks like a separate color. And another color. Let's see if that's true by going in the middle. 0.5, 0.69, 0.74. 0.76, 0.7. So yes, they are all different colors here. So that is working correctly. So now we have the wedges for the seed working and for the color working. So let's move on to the ROP mantra node. And before we dive back into Houdini, just want to say a couple things here. ROP mantra node, just like the previous tutorial, is just like the mantra node is in Houdini itself. A couple things we want to do here is make sure that it's evaluating to frame range, because we want to actually render the frames of the simulation. And the other thing that I want to mention here is we want to make each of these images that come out of here unique. So what I'm going to do is I'm going to use a wedge index, and remember that it has to be in quotes to get a unique index of the wedge, and then also the frame number, which is just the $F4. So let's go and do that. Back in the top network, I'm going to drop down a ROP mantra and wire it in. And I'm going to say evaluate using frame range. And right now I have 240 frames. And remember what we said, test small. So I'm going to change this to a frame range of 10. So I just had 10 frames, and you can see it updates here 1 to 10 automatically because it's at F start and F end. Camera 1, I don't know if I have a camera. I do have a camera, cool. So let's just look at the camera there, great. And now comes the output picture. And for the output picture, I'm going to stick it in the render folder. I don't need to know the hip name or the operator string. I do need to know the frame number. But what I really want here is the @wedge index. And that's not in caps. Let me retype that. And remember, backticks both at the beginning and the end. So I got the wedge index value, and hey, let's save it and render this. It shouldn't take long because it's only 10 frames. And 5 plus 25 is 30, which makes sense. 3 times 10 frames each. The render has finished, and let's see what we have. So I could go here to any of my work items, right click and say View Task Output. And there's one. And probably at the end is where we want to see when the particle force takes over. See a few more streams. So that looks good. Let's look at this one. And you can see that they are indeed different colors. Probably should change the seed value so we can have a more pronounced difference in colors, but 1, 2, and 3, all of them are slightly different shades here. Looks good. Okay, so that's working. Now I want to show you something while we're here. Okay, if I go here and say task info, you'll see that there's a wedge index and a wedge number, both of which are number 2 right now. So what's the difference between a wedge index, which is what we use in the file name here, and the wedge number? So let's do a little experiment. Let's just drop down a wedge. Say it has a count of 3. Okay, and we'll give it one attribute, foo. Cool. And now I'm going to cascade another wedge from it that also has 3. We'll call this one bar. And let's wire them up. Cook this one first. And again, it has 3 items, and if I look at these guys, it has a wedge index of 1 and a wedge number of 1, and this guy has 2 and 2, and 0 and 0, which makes sense. Now I'll go here, and I'll cook this guy. And he has now 9 work items. 3 times 3 makes 9. And let's look at the wedge index here. So we'll go task info, and it's 0, 0 for both these guys, but let's go past the 3. Let's go to work item 4 and do the task info for that one. And suddenly you'll see it has a wedge index of 3, but a wedge number of 0. So what's happening here is, and I think I have a slide for you, is a wedge index always goes from 0 to the number of wedges in the entire node. Wedge number goes from 0 to the number of wedges. So in this case of wedge 2, what you'll see is the wedge index will be a value of 1 through 9, because there's 9 wedges, but the wedge number will just cycle between 0, 1, and 2, 0, 1, and 2 from the original number here. And indeed, let's go to the last one here and do a task info. You'll see a wedge index of 8, 0 through 8 to make 9, but the wedge number is just 2, 0, 1, 2. Okay, so hopefully that clears out the difference between wedge index and wedge number. So the next thing I want to accomplish is to take each wedge and composite it, like do an overlay of each wedge on top of each other to fill out the picture so we have all those particles over top of each other. To do that, the first thing I do is I got to partition the frame number of each wedge together. So if I have the 3 wedges, I want all of frame 1 to be coalesced together, all of frame 2 to be coalesced together, and so forth and so forth. To do that, we'll use a partition by frame. So I'll go here and I'll delete our little experiments of wedge 1 and wedge 2. and drop down a partition. And notice that there's a lot of different partitions. There's partition by attribute, which is quite useful, and partition by expression, which I like a lot. I recommend that you go through a bunch of these because they're all quite useful. But right now we just need to do a partition by frame. So we'll just wire in these items here. And if you look at, again, any of these work items, so view task output of our ROP mantra, I didn't want the task output, I wanted the task info. There we go. Task info, there we go. You'll notice that where it gets exported, the full export name is like wedge2 frame 9, 0009.exr. And again, if I looked at any of these other ones, 8EXR for wedge 1. So we do have for each of these guys a frame number. Okay, as you can see, we now got the particle wedge with the wedge number 012 and the frame numbers. Cool. So I can now go back over here to my partition by frame. And all I'm going to say here is, well, the defaults will work just fine. I'm going to round down if it's a floating value. And let's see what happens. Let's just cook this. First thing you notice that the icon here is slightly different. It's got these vertical bars representing there's a collection or a collection of items. If I go here to my task info window, you can see that it's showing you that that work item has 3 partitioned items: ROP mantra, fetch 133, 134, and 135. Okay, and more importantly here as the output, you can see it's taking wedge 0, 1, 2, and the third frame of each of those guys. And let's just look at another guy, the last one. And task info. And you can see each one's frame 10, again, wedge 0, 1, 2. So that's worked perfectly. Before I move on, if you've been using PDG for a while, notice that there is a new icon at the bottom here. So besides clicking here to get to the task graph table to see all the information of each work item, there's now this little collapsible bar. So if you don't want to see all your work items, you could just display them or not display them. With the partition by frame, we are now ready to go and composite each frame of each wedge. And to do that, we're going to use a third-party free application called ImageMagick that we made a node for. And the website here is just imagemagick.org, and notice that it does have a K at the end here. And basically it says use ImageMagick to create, edit, compose, and convert bitmap images. So what I'm going to do here is swing over. I thought I was going to swing over. Here we go. To the actual site. And yeah, don't click up on here for the free Mac reader. What you want to do is go and down here it says the current release of ImageMagick is 7.827. So you pick your operating system. Just click on it, and it'll take you to a download page. And if you have Mac ports installed, you can use the sudo port. But if not, you can just download it from here as a tarball. And then it gives you the instructions of how to install it, which is really important. You got to really focus on how you're going to install this and where you're going to put it, because we're going to have to make a path to it in Houdini. So again, just follow these instructions, and they're for all the major Linux, Windows, and even iOS. But hey, we don't have Houdini yet on iOS. So there you go. So that's how you're going to install it. So let's see how we're going to use it. Back in Houdini, I'm going to drop down a ImageMagick top. Here we go. And the first thing I'm going to do is going to look at the parameters here. And I have a few different types of operations. I can have a montage. I can have a convert. So montage will give me like a 2x2 comparison of images, a grid, or a convert will say take it to an EXR, make it into a JPEG, and composite where I could do what I want to do in this case, where I could take all my frames of a specific wedge and do an overlay on them. So I'll say composite, and in the composite operation there is overlay, soft light, and multiply that we built in here. We'll say overlay. Now I want to show you here that in the ImageMagick there is a command. So you can put in your own command lines for ImageMagick and not just rely on the few that we supply for you. And you just really have to learn the command line operators for this. So let me just quickly show you. I'm going to turn that off so I won't forget to turn it off later. If I go to Safari and I go back to ImageMagick.org.homepage and I just scroll down a bit where it says features and capabilities, there's the command line processing page. I'll just click on it. And this is where I'll give you all the information of how to write your own commands. Okay, way beyond the scope of this tutorial, but there you go. So let's go back into Houdini now. And then I'm going to have to give it a file name. And I'll say PDG directory, that's fine. Or I could do $hip, whichever you prefer. I'm going to create a new folder called images. And that's just different than what we had for render for our ROP mantra for composite. Then PDG name, and remember from our previous tutorial, PDG name gives it a unique identifier. So if we have certain things like same frame numbers or anything like that, it won't overwrite each other. And then I'm going to need also $, let's say F4 for the frame number, and then I'll want this to also be saved as EXR. I think ImageMagick could do EXR, so we'll find out shortly. And I'll say save, and let's cook this. Oop, I forgot that I already had an ImageMagick now put down. So let's go and delete this guy and just cook him. Okay, right name, composite overlay. Let's redo that. And let's see what we have. View task output. And you can see to render quickly, I made my frames real small. And you can see indeed that I have a ton of more particles here than any individual one. And I could prove that by just going to ROP mantra, let's say wedge 3, view task output. And you can see how sparse it is over here. And if we look here, there's just a lot more particles because we combined all the frames of each of the wedges. So that's working just fine, and we could continue. While we're here, I want to show you how montage works. So I'm just going to drop down another ImageMagick. This time it's going to be set up to montage. I'll just leave everything by default here. And actually, let's go here and do something like foo underscore, just so we don't overwrite what we already did. I'll wire it up. And now if I cook this guy, and I want to see the differences between the last frame, I just say view task output. And you can see it gives me a montage of all the frames, in this case 3, of the frame 10. And I can see, if you look over here, that indeed all of them are slightly different. Very cool. I'll just delete that because we don't need it for now, and save. Now that we have our composited images, we want to reassemble them and make an MPEG-4 video out of it. So to do that, there are two nodes, FFmpeg encode video and extract images. We'll use the encode video version of it. FFmpeg is, again, a third-party application that's free to download, and we created two nodes for it. And you could download it at ffmpeg.org. And if we look at that site, here it is download. And if you want to discover more and learn about the command lines and so forth, all you have to do, and I click really quickly, is say discover more. And it will go through each of these guys. We want ffmpeg. And it will go through a table of contents and the descriptions of how it works and all the command lines you could use. In our case, we just want to do a simple make it an MP4. So let's do that. Okay, gonna drop down my ffmpeg encode video. And probably the first and most important thing is if you didn't put it into like your 1, 2, 3 commands or something like that to get the path to be known to Houdini, you're going to explicitly have to turn ffmpeg path on and say where it's installed. In my case, it's installed, I believe, in Applications Utilities. Right here. So just to make life easy so I don't forget, I'll just find my shell tool. There we go. And I'll just drag and drop it onto the shell and copy and paste the path. Put it right there. And then I'm going to say, where do I want this? And I'm going to use the videos with the PDG name and MP4. That looks fine. This is only one, so I could actually, call it something explicit, but that's fine. And I'll go here and say Dirty and Cook. Okay to save. And something went wrong. When I did that, if we go to the folder videos, render videos, you'll see that it created a bunch of one-frame videos for me. Not very useful. So I'm going to need to collect all these composites before I send it to MPEG encode video. And for those of you who've been using PDG for a while, it used to be called PDG, it used to be called partition all. Now it's called wait for all. And I'll just put that in here. And you'll see what it does is if I say Dirty and Cook selected node, it just takes all these guys and makes it into one partition. And if I middle click on it, you'll see that it has the frames from 1 to 10 on here. And it says 10 partitioned items. Great, so it's all been collected into one partition. Now let's delete these videos and rerun this guy. And you can see it only this time created one work item. Now if I try to do view task output, all it's going to do is take me to that folder because Houdini doesn't have an MPEG viewer. I double click on it and this time QuickTime opens up, and indeed you can see I have my little 10 frame concept here. And I now created my entire animation within PDG, or I should say a Houdini network brought into PDG. Okay, we're 50 minutes into this video and we completely finished our Houdini-centric particle stream where we brought it into PDG and let it be driven by a top network. So I'm going to stop this video, and in the next video what we'll do is we'll make the top-centric version of this where we just drop down a topnet and try to build the whole thing inside the topnet. So I'll see you in the next video, and I hope you enjoyed this.